The topic of this video will be catalytic hydrogenation of alkenes. This reaction is a reduction of the alkene, meaning that we add electrons to it. The general reaction looks like this. We add hydrogen gas across the alkene double bond. This requires a metal catalyst, typically platinum, palladium, or nickel, and results in the fully saturated alkane. We don't need to worry about the regiochemistry of this reaction since we're adding the same thing to each carbon of the double bond, a hydrogen. However, we do need to worry about stereochemistry. We see that the hydrogens add syn to one another. Again, this is due to the mechanism, so let's look at that now. This will be different from the traditional mechanisms that we looked at in the past because it involves a metal catalyst. In the first step, hydrogen is adsorbed onto the surface of the metal catalyst. In the next step, the pi bond of the alkene binds to the metal catalyst surface. In the next step, one of the hydrogens that is adsorbed to the metal catalyst surface is inserted into the pi bond of the alkene. In the final step, a second hydrogen atom is inserted into the pi bond, and the product is released from the metal catalyst surface. Because the hydrogen inserts into the pi bond only on the face that is complexed with the metal catalyst, we see syn addition. Next, let's look at an example reaction. If we treat this alkene with hydrogen gas in the presence of a metal catalyst like platinum, we will get a single product. Because the hydrogen is added syn, both of the methyls end up cis to one another in the product. So we get the single stereoisomeric product.